but really this is all they're doing. All the econometrics and statistics just comes into figuring out like how do we make sure that there aren't any other relevant differences, whatever, but the nature of the calculation is exactly this one. And I think that shows both the ups and the downs of this way of trying to calculate things. And then to calculate income elasticity, you look for a rich man's version of a coal mine, like something where a rich person is making a similar trade-off. Yeah?
Yeah, I'm just wondering, so what if, say, there's another industry like fishing industry, and there's another difference in probability of dying and salary.
Yeah.
And the difference between the fishing industry and, say, the mining industry gives us a different statistical value. Like, how would we consider
And the people have the same income? So the first approach is to just attribute it all to income differences between the people. And then if income doesn't explain it well, then you might start putting something else to try to explain that and to try to figure out what other things you might think to the first order affect the value of human life. Okay. So there were a bunch of studies that were done like this. And the ones that I think are most well respected are these ones by Viscusi, or at least the ones that are most respected by the survey paper by Viscusi are the ones by Viscusi. And those find human life values somewhere in the range $4 to $6 million. I think that these come from like from the early 80s, so you'd probably have to increase that for inflation and income growth and so forth. Probably closer to $10 million or something like that. Okay, so perhaps the most ambitious version of, or application of benefit cost analysis was the Stern Review of Climate Change. And it was commissioned by the British government along with other organizations with the goal of evaluating the economic benefits and costs of climate change. And it proceeded in several stages. And Matt Stern? Or Matt Solomon, sorry.
Yeah.
I just said S here and I was Stern and Solomon. What were the stages of the Stern Review? What were the things that they had to think through to evaluate it?
Well, they looked at sort of like what was going to happen, like basic.
Yeah.
Water was going to rise, or temperature was going to change. And then they looked from there at sort of like who was going to be affected. So like a lot of sort of third world countries are going to have like the water's going to rise, you know, crop levels are going to change, and sort of how that's going to affect people.
Yeah, that's great. Yeah, and let's break that down a little bit more in detail. So the first thing that they looked at was to determine what were the sources of the gases that were affecting this. So is Hao Yan here? Oh, yeah. Oh, you're Andy.
Yeah.
Okay, How is Andy? Okay, thanks. So what were the largest sources of greenhouse gases that the Stern Review found?
I think they looked at factories as well as just remember
Factories?
Yeah.
Do you think anyone else remember anything else? Yeah, okay. Yeah, that's like actually the largest single source. So cows farting is basically like the biggest source of climate change. So actually you could accomplish a huge amount if you like just reduce the number of cattle in the world. Like if you reduce the number of cattle in the world, I think it would be like 3 or 4 times bigger than taking all the cars in the world off the road. Because methane is something like 80 times more powerful as a climate gas than is carbon dioxide. Deforestation is another important source because that was taking carbon out of the atmosphere. Then you have to determine the effects of those gases on global climate change. Jackson, what were some of the effects of gases on climate change?
So the biggest effects are going to be you know, the increase in temperature, which is going to cause different agricultural patterns. There's going to be
And how does that work? Why do these gases increase temperatures?
Well, the gases in the atmosphere prevent radiation from escaping.
Yeah, they sort of trap things in the air. That's right. And you use large-scale climate models to try to evaluate exactly what those effects will be. They're extremely uncertain. So usually you try to get some distribution of outcomes rather than like figure out exactly what's going to happen. You try to figure out what are the range of things that could occur. Then you have to determine the economic effects of those changes in the climate. And Edward Lieb is not here, is he? Anyone else want to talk about the, okay, I'm going to remember your name. Sorry, what,
Ryan.
What, Ryan? Yeah.
So like some economic changes are like when the temperature rises, ice comes and melt and people might need to move from coastal areas.
Yeah.
It might change productivity of like coastal areas.
Yeah.
And like different temperatures could change like different places you can grow crops.
Yeah, agricultural yields, disasters, flooding, things like that. Or just, it could get unbearably hot to live in a certain place, right? Okay, then you need to determine the extent to which adaptation, people sort of like changing their lifestyles to deal with the new environment, might mitigate or not mitigate these harms. And David Mao, could you talk about the extent to which adaptation, like what people might do to adapt to the environment and how much that might reduce the harms caused by climate change?
Well, people learn like from patterns. So if say the temperature rises and they see that certain crops aren't working in certain areas, they'll just grow different crops or they'll move to a different area.
Yeah, people moving areas is a big way of that. So I think one real problem with that though is that the government, typically what happens is when there's a lot of flooding, is the government comes and they bail out the areas that are flooded rather than making them buy insurance against the flood. And that doesn't make people bear the costs associated with the flooding, and therefore it makes them less likely to move away from those areas. So that was a big problem with Katrina, is they didn't really make people pay for flood insurance, so not that many people moved away from these dangerous areas. One example of that, there's a study by Rick Hornbeck, who's going to come give a talk here a week from Monday, who looked at the Dust Bowl. I don't know if anyone's heard of the Dust Bowl, but during the 1930s, all the topsoil in the Midwest blew off of the ground, and that made it really hard to grow crops there. And people should have migrated away, but there were all these problems that made it hard for them to migrate away. It was hard for them to sell their land. It was hard for them to find jobs in California with some unemployment, and that made the effects of the Dust Bowl much more serious than they should have been. People had just been able to adapt and move away. You can do a similar analysis for other impacts of climate change, or of other impacts of greenhouse gases. And what are the other types of impacts of greenhouse gases other than just the climate changing, Matt? Klein. Do you have some thoughts about that?
Well, I mean, the climate change is the biggest one.
Yeah.
And it's going to cause things we haven't talked about yet, like ice caps melting and stuff like that, which are kind of, like
irreversible.
Irreversible costs that we don't really consider that often.
But did you see in the article other effects that carbon gases have other than just on the climate?
I don't remember.
So they can cause salinification of the oceans.
Okay.
And they can also cause like algal blooms in the oceans, which because there's all this CO2 available, all this stuff starts growing in the ocean, that might make it really hard for fish to live and stuff like that. Okay, so corresponding to the distinction between cap and trade versus the Pigouvian tax, there were two approaches the Stern report took. And David Wayne, do you want to talk about what those two approaches were?
I think one of them was assessing basically, like, I think it's called business as usual.
Yeah.
And basically just calculate like what the effects would be if current business practices were kept going.
And they calculated the marginal benefit of reducing a little bit from the business as usual scenario.
Okay. Yeah. I don't remember the second approach.
Does anyone else remember what that was? Yeah, go ahead, Andy.
They also try to calculate what would be, I guess, an optimal level of the level of carbon.
Yeah.
And then just like sort of the cost and benefits versus the amount of investments you have to make to reach that level.
Exactly. So like the first one was that you start at the business as usual scenario, and the benefit of taking that approach is you don't need to think about what technologies become available, how cheap it is to mitigate carbon, et cetera, and therefore you need less assumptions. But it's really problematic if the effects are potentially highly nonlinear. So if the business as usual scenario is like totally different than the optimal scenario, the tax at the business as usual scenario is going to be completely different than the tax at the optimal level. And it's possible that just putting on a tax could ignore the fact that if we go beyond some point, things could get really, really, really bad, you know, and that's the problem with this this scenario. Now they came up with an estimate of $85 per ton as the marginal tax that should be put on carbon. The second approach was to figure out what the socially optimal level of carbon is, and that dealt really well with the nonlinearity and so forth. But the problem is it required you to make all sorts of assumptions and guesses about what technologies would become available. And they estimated that it would be optimal to try to stabilize carbon at somewhere between 450 and 550 parts per million. So I think that, you know, looking through the Stern report makes you realize just how hard it is to really think about one of these policy questions, right? I mean, that statistical value of human life thing already had all these heroic assumptions, but think about all the stuff that goes into here. The climate model, all this stuff goes in. And, you know, just to give you one example of an important wrinkle that shows up in these analyses is that a lot of the harms come from the possibility that there would be some terrible catastrophe. Not just that things will get a bit warmer and whatever, but that there's some chance that like polar ice caps melt and then the whole world becomes like Venus or something, right? There's these solutions called geoengineering, which basically means you put these like particles in the atmosphere, they reflect light and they cool down the earth, right? And everyone thinks that those would be sort of bad ideas. They would do all sorts of bad things to the environment, but very few people think they would be totally catastrophic or they would like cause the world to turn into Venus or something like that. So at least you could avoid some of those most extreme bad outcomes by using those geoengineering solutions, and that could dramatically reduce the harms from climate change because you sort of cut off that tail and replace it with just bad stuff, not super, super bad stuff. Yeah, Kevin?
Why does the second option require a more thorough understanding of technology than the first one?
Because the first one just says, look, business as usual is the scenario where we just keep doing exactly what we're doing. And then you just need to ask if carbon was reduced a little bit below that, what effect would that have? Whereas the second scenario requires you to actually figure out what is going to be the cost of reducing carbon by every single amount we could reduce it. So we can construct sort of like a supply curve for carbon reduction and then intersect that with the demand curve that comes from the first analysis.
Okay.
You see what I mean?
Yeah.
And that takes a lot more analysis. Okay. So the Stern review focused on sort of hard economic costs. But of course, this leaves out lots of stuff like, do people like being in warmer or cooler climates, right? Now that might sound frivolous, and in fact, Clemence has already, maybe I should call hers a giggle about that. But if you look at the difference between real estate prices in California and Chicago, you know this is a really big deal, actually. For like the same place that I live in Hyde Park, if you wanted to get that in San Francisco, it would cost like 4 times as much, basically. And so the question is, you know, how do you quantify that in an objective manner? One way is you could look at the differences in land prices, right? Just like you do with the statistical value of the human life. That's a natural first approach. Another example is how much do people care about all the animals that will die as a result of you know, climate change? Well, one thing you could do is you could look at the value of all the tourism to those areas, but maybe there's more value beyond that. And the question is, how do you quantify that? Well, one way you can do it is figure out what other decisions governments make in other areas to try to do these things and use that to try to measure value. Another thing is, you know, cities or civilizations could be destroyed. Those might have value just beyond their market value in just existing. And how do you quantify that? Another area is that, you know, we might be able to figure